The next question is January 09, old module 2 or AS2, and the topic was, or the title of AS2 was waves and photons. So question 1a, a wave of fixed velocity passes along a stretched string. Figure 1.1 shows a graph of the displacement d of a particle of the string against time t, and it shows you a graph there, and so it's displacement up here and time across this axis here. It's a very odd scale, unfortunately, where there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 squares, and that's worth 0.01 seconds. So they really were quite horrible there that they used a scale like that. But anyway, you just have to do your best with it. So question part 1 says, describe the direction of the particle's displacement relative to the velocity of the wave. And you can see that the displacement is going to be at right angles to the direction that the wave's travelling in. And so the direction of the wave's displacement is perpendicular. And that suggests that this is a transverse wave. And that's the next answer to the question. The type of wave on a string is transverse. The next question says, determine the amplitude of the wave. And if you look at the wave, it is of course the height above the rest position. You know that this is 9, and so therefore, given that that's divided into 3, this must be 6 millimeters. So the height of the wave there is 6 millimeters. That's the amplitude. The next question says, determine the frequency of the wave, and that's where the difficulty comes in, I suppose. Well, it's not too bad actually, but if you have a wee look there, you can see there's one full wavelength, and it's taking you across 1, 2, 3, 4, 5, 6 squares, and then there's another 6 squares. It gives you another full wavelength. So we'll just assume that 6 squares is half of 0.01, and therefore the time period there for one complete wave is 0.01 divided by 2, which gives you 0.005 seconds. And therefore the frequency is equal to 1 of the time period, which is 1 over 0.005, and that answer then gives you 200 Hertz. The next part of the question then tells you the velocity of the wave is 80 meters per second. Calculate the wavelength of the wave. And this is part 4 of the question. So this is just very straightforward. V is equal to lambda f. We now know f. We're rearranging that to get lambda, so it's V over f, which is 80 divided by 200, and that gives you an answer of 0.04 meters. And the last part of the question, calculate the phase difference between the point A on figure 1.1 and the origin S. So if you have a wee look here, this isn't just as straightforward. You can see there that there's where A is, and that would be correspond to a quarter of a time period ahead, and that would be half a time period ahead. So if you try and figure out, you can see there, that would be worth 180 degrees or pi radians if A was here. But A is actually 2/3 of the way along here, so we'll assume that that is 2/3 of 180 degrees in front. A is 2/3 of 180 degrees in front. And so that comes out to be 120 degrees. Or you could express that in radians. And so it is 2/3 of pi radians. And when you work that out, that comes out as 2.09 radians. So there's the two options of the answers that you could have.